Yes, you did very well. Excellent. So much talking, just to bridge some time. Well, a lot has already been said about myself. In the Kotlin community, well, people have seen and know me. Java people maybe a bit less, but as I said, quite some stuff has been said. Very quickly, just to go through. When you look at me, indeed, I'm trying to program in Kotlin as much as possible because it's just a lot of fun. But when you look at my career, I also did quite a bit of Java and also about 5 years of Scala. Heavily investing in the Scala ecosystem. But by now, I actually mostly write coding in Kotlin, which also has some reasons. You have heard that, right? I'm a trainer and I really love to train. And I figured recently how many people I've trained so far, and it's about 1,000. Just insane number if you think of it. Well, if you just keep on doing this long enough till you have gray hair, then eventually you get there. But I'm also really pleased to kind of mention is that I was able to make some tailor-made programs to kind of really bring Kotlin on a high level in organizations, which also actually is applicable for these, right? So adoption trajectories, figuring out how can you actually embrace such a new technology. And I'm also an advocate, as you might know. I'm the Dutch Kotlin user group chairman. We've talked about Kotlin Dev Day. If you want to know more about Kotlin, there are a lot of talks I've given, also some webinars where you can, well, hopefully get a bit enlightened if, you have some time to do that. And I also have some good contacts with the Spring Boot Kotlin team, but also the Champions team, so it kind of feels that I have the honor to be a bit at the fire where all this nice Kotlin development is taking place. Okay, so nothing about me, actually quite curious about you. So who of you is using Java as a primary language? Okay, that's a minority. I actually thought it would be 50-50, but okay. So who is using Kotlin as a primary language? That's the other half, right? And who is a bit in between? A few, not that many, Cool. So before we start, I think this is an important thing to mention, or at least the question to ask, is there something like the best language?
Kind of.
And I think here, exactly on what it depends. I don't think it depends. There is just nothing like a best language. That really depends, not necessarily on what, but it depends actually on the fact that you are kind of very hard to grasp. In the sense that it has a lot of subjective factors in it. However, if you look at it from a different angle, we are not really programming COBOL anymore, right? So apparently there is some evolution, so these preferences change eventually. And on what they change, in my experience, is quite an organic process, which, well, we also will more or less see how this can be captured in, with Kotlin. So that's definitely a fact. The code or the languages used today will probably not be the ones we use over 5 or 10 years. Maybe not. COBOL is still there, so some languages definitely will survive, other languages maybe not. Well, I'm actually really focusing on the very thoughtful way of defining whether to use a language or not, because this is not how I see it happening in practice. It's definitely a very advisable thing to do. However, this is not how it goes. So what I see often in practice is more or less this, right? So you have some people, some developers, and I will look at these profiles in a minute, that just like to try out new things. See whether these things can help them, just maybe because they're bored with what they're doing. There are many kind of arguments why someone is just trying something new, is not happy with what he's doing. You also have other developers who really love to stick what they've did for years, because this is where they're maturing and they like to repeat this over and over again. Yeah. And for both you have some advantages and disadvantages. Well, the profiles I've seen so far that kind of are catalysts for embracing something like Kotlin is this kind of engineer. So you have Java engineers that are a bit pragmatic. They're not really too attached to Java. They think it's a tool to make my job. It's not kind of religion. So maybe let's see if another tool can help me to get there faster. And they're often experienced people. Then you have these guys, the curious developers. These are the ones that are kind of very quality-minded, so they like this readable, concise, maintainable code to write, and also looking tools for them. I think when we had Java and Scala, these were probably the people who moved over to Scala. They found a new tool to make just better, more usable, and so on code. Then you have the last group, which is kind of interesting, which are actually new developers, juniors. And I've talked to quite many of them, and for them, it's kind of interesting to hear their verdict is, why should I use Java if I can use Kotlin? They look at me and think, why shouldn't I do that? That's kind of understandable because, first of all, they have not kind of a baggage. They don't have the experience built up. They're kind of free, don't have to unlearn things. When you know a tool very well, you always come with an unlearning part. Often, because they're younger, they also like to jump on different bandwagons, right? That's also a bit of a danger. So these are more or less the profiles that can be a catalyst for Kotlin. And, well, here I'm actually curious how this more or less went in your case. What I often see is that you experiment in an area which doesn't have that much impact, right? You don't want to have an irreversible outcome when you start with Kotlin, as we just heard. That's definitely not an area where we want to use Kotlin. So you probably start using Kotlin in tests. That's safe. It's fun to try out the language. You also can maybe rewrite a certain part in your Java application. As you might know, Java is fully interoperable with, Kotlin is fully interoperable with Java. So in that sense, you can write Kotlin code that in Java looks like as if it's Java. So these two ecosystems can be nicely together. Or, and I think that's in my experience the best approach to do it, just write an application from scratch, fully in Kotlin, and then see how you like it or not. So who of you has used the first approach? Kind of playing around with Kotlin, with tests, and see how this works? Well, it's actually not that many. Okay, interesting. Second approach, just take an existing Java application and then write some stuff in Kotlin. Okay, cool, also not that many. Then I assume that most have just written a system in Kotlin. That's indeed the most part. Have I forgotten another approach?
Yeah, when you start adding Kotlin files to Java project.
Yeah, okay, that's actually what I mean with the second one, kind of. Yeah, okay, you extend actually existing Java application with new Kotlin feature. Okay, yeah, cool. Yeah. Okay, nice. Yes?
I was basically dropped into a team that had a Kotlin code base, but I had only Java experience.
Okay.
So I had to learn Kotlin.
Oh, okay, so you were forced. Yes. So you were forced to happiness, so to say. Okay, what I do not often see in this phase is when people start experience with Kotlin is this. Right? We are developers, we're all stubborn, we really think we can do this ourselves and nobody gonna tell us how to do that. Even though I'm quite sure that this can help you tremendously. So if you would just embrace some expertise, then things like these you can avoid, right? Lombok in Kotlin. I know teams that have spent 2 weeks to put Lombok in Kotlin. It's a fun experiment. What you also get, and we'll talk about this also a little bit later, is because, especially moving from Java to Kotlin, you are in Java, this is your daily driver, right? So it's also logical that you will apply the concepts you learned in your new language. So you will try to enforce them on the new language, which doesn't necessarily bring you the best results. Also, these I have seen quite often. So when you've used Reactor, then you would just use Reactor with Kotlin. Even so, with coroutines, you really can make your life so much simpler and easier. And then when you show it, you think, oh, okay. But by then, quite a bit of damage has already happened, and this needs to be reversed. So if you can avoid that, that would be great. So in that sense, you could establish in the early phase kind of a good perception what is decent Kotlin code, maybe not perfect, but decent. And also, of course, help then in the process later on. So who of you who has started Kotlin has had more or less a bit of help in that area? I see, that's okay, a few ones, but not many. It's often you just try it yourself. That's also a fun way to do it, but you probably leave a bit of trail of technical debt behind you.
Yeah. Well, the Kotlin code labs are also pretty good ones. That's also how I learned Kotlin. I went to a meetup and then we did training on that part.
Yeah. That's indeed also a good approach, just to train before you start doing it. Yeah, cool. So then actually, in my experience, comes the most interesting part, which is you have now a core team that believes, or is persuaded that this technology really can make a difference. You need that belief. So I think it's not really kind of a decision-making process. You can sit on the table and do it. You have to try it out for a certain amount of time, because it will, of course, impact your whole infrastructure, your whole software stack tremendously over the years. So it's something you're probably not gonna do in one session. It's a process. And this is actually what you will have to do, so persuade your peers, but also management, that this is a good route to follow. Then also talk a bit about onboarding. Well, what's very important is when you persuade your peers, you're actually trying to persuade people who have used, most of the time, Java, and they got their job done, right? They didn't just deliver crap that they broke in production. They delivered decent code. And maybe some of them think it kind of works for me, so why should I do it? So good arguments there would definitely help. I'm going to show a bit some examples now, because it's a meetup and I think it's also nice to see some code. I also could have skipped it, but I thought, well, just look at some code. Not really kind of showing feature Java Kotlin, but also trying to give you a higher view on the concepts that are in the language and what these concepts aim for and what you gain with the concepts, rather than just one feature versus the other. There are many to choose from. Of course, you don't have time for that, so I started with an example you probably have seen quite a few times, right? You have this Java class with all the stuff in it, and then you have the Kotlin counterpart, which is very short and concise. And that's already impressive by itself, but there's actually more behind that. So if you look closely, in Kotlin you see this combination of variable declaration and a constructor declaration all in once, which makes it nicely concise, but there's actually also a safety feature behind that. In Kotlin you have the concept of this primary constructor. And why have a primary constructor? Well, because a primary constructor ensures that whenever you create an instance, that this instance is kind of fully operational. In Java it's very easy, when you don't use final fields, to just create instances which are not fully operational. So when you then call stuff, you get null pointers. So in Kotlin, to avoid that, this is why they kind of limited the creation of an object by introduction of this primary constructor. Another very simple feature, which is already removing a lot of code, a lot of boilerplate, default arguments for constructors and methods. So overloaded methods of constructors, something you almost never do in Kotlin. Have you all thought of it that Kotlin only is possessing kind of box types or just objects in that sense, so no primitives? And that, of course, also has tremendous impact on the complexity, because Kotlin says it's a compiler concern, compiler decides whether it's a primitive or not. And as such, we see later on, you have quite some benefits. Then if we have the more advanced features like operators for DSL-like functionality, but let's not get too far there. Well, who is using classes? Nowadays we use records, so who is using mainly records in Java? There are people who do. It's very common nowadays, right? Often people think records and data class is the same thing. It's not entirely the case. For a certain part they are. What you can't have in records is mutable state. In Kotlin you can. Doesn't mean it's a good idea, but you can. What you have in common is this, right? Nice toString method. You have a nice equality method based on data, so equality by value rather than by reference. And what's really missing in the record is this copy method, which allows you to create slight deviations. In records, you have to copy all the state manually yourself, which of course is tedious, but also error prone. And the feature enables that in Kotlin is basically named arguments. Because we have named arguments, we can have such a feature, which Java doesn't offer. Yeah. And destructuring that can sometimes help you with readability. What's also interesting is that data classes work with GPA, whereas records do not work, at least not with entities. You can have them as use, but not as entities, which I found very surprising that a Java framework supports Kotlin better than, okay, that's what it is. And also here, that's why actually in Kotlin you don't need builders, because you have default arguments. It's a very simple basic feature that allows you to make a lot of stuff obsolete. Okay, so this was a bit the introduction. Last but not least, what also really helps you to gain an overview of your domain is this simple feature that you can put multiple public classes in a single file. And but as doing so, you simply scan a certain domain and you know how different entities are related with one another. Whereas when you just have to even small clauses in different files, just doesn't help. It's very minor, but it helps. Okay, so if you had to explain to a developer or maybe also a manager, this is basically what you gain, right? 30 to 40%. Code reduction is not a goal by itself, but more code clarity definitely is. because you will have to write, read, maintain, reason about less code, which in the long run makes a difference. Safety is one of the key features, so null safety is something I guess all Kotlin developers know and use on a daily basis. So for that, this group is probably not that interesting. For the Java people, it might be interesting. So what Kotlin was realizing is that this $1 billion mistake, as null pointers or null errors are also called, is something that really should be terminated forever. And they came up with a very solid solution for that, which is actually incorporating nullability in the type system of Kotlin. That's what they did. So when I want to use something like null, I have to assign this question mark to a type, meaning that this is a nullable type. So this type can be null or the real instance. That's very convenient in various areas. So first of all, when you just create a graph of objects, it's like as if nullability is not there, right? You just would instantiate such an object graph. When you traverse it, there are very convenient ways to do that in a safe way. So if this question mark syntax, and whenever you hit null in one of the leaves, then it would directly jump to the else case. Compile is also smart, so when you do some if checking, even in a deeply nested part, it knows, oh yeah, you've checked the whole chain, so by now, till now, you're safe. All these intermediate values are not null. So compiler also helping you there, and with let, you can also more or less achieve the same. In Java, and that said, not surprising, because when Java started, nullability wasn't a big issue, so they kind of, over the years, tried different things, annotations, and I think by now it's optional. That's the kind of ingredient you would do. And you see, optional has just a lot of wrappers. So when you use optional, then you get wrapper or wrapper or wrapper. And when you want to unwrap, well, you get a lot of this flat mapping code, which is doable for optional when it's also combined with collections, and if you combined with some completable future or some mono, then you get, well, code you're probably not gonna.
Optional can still be null.
What?
Optional can still be null.
Yeah, exactly. So this is the let, this is the other case, and just reading this is kind of really a hard thing. And indeed, the way this works in Kotlin is if I would assign null to a normal type, I get a compilation error. So at compile time, I kind of pointed to, hey, this is something you cannot do. This is fine. When I try to access a field that is nullable, I also get a compilation error. Compiler helps me. Let the compiler work for you. So I always have to address a nullable field with question mark, and as such also take care of the else case. In Java, null can be assigned to anything, and when something's wrong, you get a runtime error. That's the evil thing, right? You want to avoid runtime errors as much as possible. And just said, like, really looks silly, but I've seen this in code. You can assign null to an optional. As such, you also get runtime errors. So what safety features deliver, and said there are more like constructor and some others, is basically this. You really get about 30% less bugs in your code. And in the long run, that matters, right? And that's surprising also the experience I had. I came from Scala back to a company where they did some Java, and I started coding Java, and also at no point I thought, wait a minute, what's going on here? I cannot program very well anymore. And I realized that it's actually not me, it's the language. You also can go the other way around. So when you program with Kotlin, all of a sudden you get code that has less null pointers, so you think you program better. Maybe it's language. Okay, no wonder it's the most loved feature. Functional programming, also an interesting feature in Java, which has kind of been put in later on. You get all these functional interfaces, right? In Kotlin, you have syntax for that. And why is that handy? Well, a function interface is an indirection. What you want to know in a function signature is what goes in, what goes out. Whereas a function interface doesn't tell you that. So you always have an indirection. As such, using functional concepts in Java has this indirection. So it's not convenient to use. Whereas in Kotlin, just by reading it, it's more natural. As such, you probably also will use it more often. Then you also have this kind of challenge in Java, right? Having unchecked exceptions, especially in the context of lambdas. You need to catch them all the time. Doesn't really look like a terrific code in that way. If, for instance, just want to skip an exception, then you have to take refuge in optional. Then you again need quite some code to get rid of the optional. Here again, I have to catch, and if I still am not happy with the exception, I would throw it as a runtime exception. It just gives you a lot of overhead. Even so, that might kind of give an illusion that you're safe because you catch exceptions. The exception that is probably most likely to happen here is in max. Because when a collection is empty and you pass it to this max method, you get a noted element exception. So it gives you really a false sense of safety. In Kotlin, this is the counterpart, map not null. Actually a nice combination of mapping something and filtering out the nulls. Nice way to do exception handling. All, of course, in Kotlin, only checked exceptions. And these higher order functions that allow you to very quickly and easily do whatever you need to do without all the boilerplate you've seen before. And here we see actually a variety of features at play that make Kotlin a great language. You have these very powerful higher order functions, which fully have nullability incorporated. No checked exceptions help you. And the extension methods, for instance, in the reading of a stream, it, open stream, reader, and so on, is also actually avoids using utilities. So a lot of kind of better included approach we see here happening. Collection is something we use on a daily basis. Also here, last example. So I have here a series of products, product name, and then the numbers would be some rating, product rating. And what we try to do here is figure out the average rating per product. And this is how our Java code looks like. If you would do this in Kotlin, it's basically this. Associate name to the average rating. That might sound like a kind of a bit thought of example, but this is really more or less the ratio you get when using Java collections over Kotlin collections. So why is it in Java so complicated? Well, there are different reasons. First of all, you have the stream interaction, which is added for backwards compatibility because you didn't want to change the original interfaces. These are these stream gatherers, you might have heard of them. They are not in the API, they're added later on. Because changing APIs in Java is very tough because you don't have extension methods, right? So you really have to think very thoroughly what kind of APIs you offer, whereas in Kotlin you have these extensions, easily can extend existing APIs. No named arguments, you really don't know what's actually going into the collect here. Here we also see the drawback of having primitives and box types, so you need to convert from one to the other. There you also need to add a look for nullability. So who of you knows Rod Johnson? That's a few. Who of you knows the Spring Boot framework? Everybody, great. So you know Rod Johnson because he created the Spring Boot framework. And about 2 weeks ago, we gave an interview on JetBrains, and the lack of collection support in Java actually made him
And indeed, Java has
go
improved a lot. But I eventually got sick of, lifting to and from streams, which I do think, frankly, is embarrassing. Like, there are many good things about modern Java, but that is embarrassing compared to other platforms. And I think that strictly speaking, I think I had been looking at some particularly horrible collection code, and I was walking the dog to the dog park. And by the time I got back from the dog park, I decided, okay, better try Kotlin. It's got to be better than this. And I would say I found the learning curve exceptionally easy. And I have now, I would say probably within 2 months of starting Kotlin, maybe less, maybe it was more like 4 weeks, I basically had no desire to write Java at all. So like all the code I write is now Kotlin. And having said that, I'm never going to be a Java hater. In fact...
Yeah, consider a good time. Let's move on. So I think it's also well balanced. He's not bashing Java. He just has seen that for what he wants to do, Kotlin is just a better solution. In the trajectory of pursuing your peers, you also will encounter Kotlin skepsis, which of course is perfect, right? Whenever you come up with new stuff that has some impact, you better have someone who is skeptical about it and challenges you so that you really kind of come up with a very well thought of the reasoning behind it. So one of the reasons I often hear is this one, that Java is evolving fast. And that's true. So we get all these kind of interesting things. In Kotlin, they have really been there for quite some time. String templates already are gone again in Java. Also, virtual thread is often mentioned. Yeah, but Java's virtual thread are on the JVM. So the good news is Kotlin also has them. So, and I think to a certain degree personally, but that's really what I see is Java definitely will continue playing a role. But this is actually what's fundamentally the issue with Java. So all this new stuff in Java is great, right? These are really modern programming paradigms that kind of are aligned with kind of best practices where you can excel. The problem is that the foundation is kind of not solid. all these aspects here, like the functional parts, the streams, the primitives, exception handling, safety, these are the things that really get in your way. They're not spectacular, and for these, there are also no really solid solutions. So if Java would be able to resolve these, I'm also a person who would consider writing Java again. But up to this point, I would be not. And in Kotlin, and that's because Kotlin has been, it's actually, is Kotlin such a great language? Actually, Kotlin is just a piece of theft from various other languages, right? Standing on the shoulders of giants. What Kotlin has done very well is not reinventing the wheel. What they've done is they have looked at various languages where they figured out which parts now were really kicked ass. And these parts, they integrate into one whole. So in that sense, they really almost didn't invent anything. They just went shopping at the right place. And it's, I think, not really the kind of cool advanced features in Kotlin that make a difference. It's most these things, right? These default arguments, no primitives, exception, no safety, and so on. Kind of basic features that are not as impressive. They make the difference in Kotlin, but also the foundation of it. On top, you have then a bit the higher level features, like really great collections, really good function support, and as such, makes it a great language. DSL support concurrency, also if it wasn't there, it probably still would be a language that can make a great difference. Okay, what's really important in this adoption process is not necessarily showing these examples that might be kind of fun, but it's actually this, which I also do not see happening very often. It's facilitating the adoption process for developers. So that's what I've seen happening quite often. A community is built in a company. So who of you has built a community when Kotlin was adopted? Yeah, Bol did it, yeah. I also know the Rabobank, they did this extensively, but that's not that many actually. ING also has no community? Yeah. Yeah, okay. Yeah, okay. So when you haven't heard of it, then apparently not. Yeah. The? Okay, they also have communities. Yeah, yeah. Yeah. ABN AMRO also has. So by the way, I just figured. Yeah, yeah. So that definitely helps because then you get external speakers, experience from outside the company, just to get a bit more traction. What also really helps is this: create an onboarding team. Some initializer projects which have pre-configured all these quality checks you would do in Kotlin, so that you don't have to reinvent the wheel. It's a minor effort, but can really give a boost for projects who want to try out Kotlin. And then also some coaches that maybe you can hire for an hour or two, because in an hour you can already tell someone so much which would help you to not make the same mistakes over and over again. That can really boost your adoption tremendously. Same here, offer some self-study material, maybe organize a course. That's what I've seen in Rabobank. It's actually what we did there. For the really basic stuff, you had some self-study materials made by developers, some Udemy course, then also some just courses organized, so you get things bootstrapped and started. And when you nurture this process very well, then adoption really will fly way, way better than if you just think, okay, now we have these nice samples, Java and Kotlin, and it's gonna fly. It's probably not gonna fly that well. And this is more or less the whole meme. You probably have heard of it. It's often a reaction also got. Many Java devs, yeah, they are kind of happy with with the language as it is. When you give them opportunity to try out, then it's better. So to round up, actually almost round up, that's also a very important aspect of the whole adoption journey. Getting developers on board is not enough. You also need to persuade these guys. The business case. So what is the business case for Kotlin? There's an investment, and this is basically the major investment. You have to invest in training. We just heard Rod Johnson, it took him about 4 weeks to 2 months. I think within 3 and 4 weeks you can be productive if you get a bit of guidance. And the return investment probably have within 1 to 4 months, depends on the skill of your developers. But within 4 months you definitely will see return investment. And this is something you have to invest. You have to be ready for that. What are the gains? Quite a few would say, well, we talked about this, right? Your code base will kind of shrink. You will get less bugs just because the language helps you with that, and in that sense also less issues and so on. And this is, I think, one of the key features why Kotlin is still popular and Scala is not. Kotlin is fully aligned with the Java ecosystem. So that's also really my strong advice. Keep on using your Spring Boot. Don't go over to Keytor because it's Kotlin. It's not going to give you any benefit. Not when it comes at least to adoption. Scala also didn't enforce you to learn a new language, but it also forced you to use a total new ecosystem, which there is a lot of investment in new ecosystems. So also the the bail-out approach in this case is also, of course, better to grasp when you could go back to where you came from. That's, of course, also a nice advantage to have. They don't have to have a big bang solution. You can do it alongside Java. We'll see later on, you need a strategy for that. Otherwise, it can also get messy. So that's an advantage, but also a disadvantage. It's a balanced thing. There are good players behind it, and they're very pragmatic, right? JetBrains really believes in a language that needs to help you. That's their whole philosophy. So, and Google is also backing it, so strong players there. And JetBrains, at least, is in Europe, so. And apparently, definitely not for all Java developers, but for majority who will switch over, they will like Kotlin. They're not going to dislike their job. This is also an important aspect to take into account, finding talent. There are definitely more Java developers out there than Kotlin developers. That's a fact. However, depends how you frame it. If you do Kotlin, they also might find you because they want to do Kotlin. So they look for companies that do it, and as such, you probably don't have to look for them. That can be an advantage. And that's what also see, Java developers can learn Kotlin quite fast. And when they're willing to learn it, they're probably also quite open-minded and also more capable of learning new stuff, which says something about their skills. However, I think the real crucial part boils down to this. What kind of company do you want to be? You get your stuff done with Java, that's sure. You get your stuff done probably a bit better with Kotlin, but what does this mean for engineering culture? So is your engineering culture more geared towards these values, traditional, conservative, ceremonial, or is it more progressive, more pragmatic? And in both, there are values. There is value. It doesn't necessarily mean that one is better than the other. The left was probably a bit more boring, but it definitely has its benefits because it's more steady on and so on. Whereas the progressive part, especially in the beginning, of course, enforces you to do some investments. Okay. Then you probably also have embedded some quality tools in your build chain. And this part is also very important, create a roadmap. You need to know how you address existing Java code bases. If you just let things happen, you're probably gonna kind of not really appreciate it in the long run. So what you do with great applications, maybe end of life you keep, active applications you probably have a strategy to kind of introduce new models, but you also shouldn't forget that just rewriting code, no PO is really looking for that. So who is funding that? New systems, that's at least what I see, for instance, Rabobank, they just get the chance to choose Kotlin or Java, but you need to kind of address this explicitly. Otherwise, the chance that you get a mess is quite imminent. Well, this is actually where I often come in-house training program. So what I see often is the following. For these parts, master Kotlin syntax, write kind of Java-ish Kotlin, often self-study material is sufficient. I actually almost never do courses for this phase of the journey. I would say it would help you, especially when you really start from scratch, so when there's no Kotlin knowledge at all in the company. I've done this for companies, and they appreciated that, so they got from the start kind of a good wish, yeah, this is how I should use Kotlin so to be effective. The interesting parts often comes in these areas. So idiomatic Kotlin, a bit advanced features, also concurrency. So when you have concurrency use cases, which I'm very grateful that Paul has, right? Paul has a lot of these very advanced concurrency use cases. There, in my experience, it really helps to do a training by someone who's experienced with that. Also there, of course, you figure it out yourself. That's possible, but it comes with a quite high price. And with that, I think you should be able to enjoy all the goodness that's in the language. Thank you.